What if you could build your own smart home using just Arduino and cardboard? In this video, I'm going to show you exactly how to do that. This small house may look simple, but it's packed with features. You can rotate a knob to automatically open and close the front door, monitor temperature and humidity in real time on an LCD screen, and even trigger an alarm system if someone tries to break in through the window. And the best part? It's cheap, beginner friendly, and perfect for a school science fair project. If you're new here, welcome. This is lesson 21 of our 24-part series called Arduino for Beginners, where we build projects step by step. Alright, let's get started. To build this project, you need Arduino Uno, input-output expansion shield, I2C LCD module, rotation sensor, servo motor, DHT11 sensor, push button, blue LED, red LED, buzzer, and an infrared proximity sensor. Don't worry if this looks like a lot. We are going to connect everything step by step. Before we start wiring, you might be wondering where all these plug-and-play components came from. I'm using the Mind Plus Arduino coding kit, which is designed specifically for beginners who want to learn Arduino in a practical way. This kit was kindly provided by DFRobot, the sponsor of this series. They are one of the leading companies in open source hardware, and their store has a huge variety of components, from simple sensors to more advanced modules. If you want to follow along with this course more easily, I highly recommend checking out the kit using the link in the description, and of course, feel free to explore the store for your own projects. Big thanks to DFRobot for supporting this series and helping make STEAM education more accessible. Now let's jump into the wiring. We are going to connect everything in small groups so it's easier to follow. Let's start with the display. Connect the LCD module, SCL to A5, SGA to A4, VCC to 5 volts, and GND to GND. Next, the input sensors. Connect rotation sensor to analog pin A3 and the infrared sensor to digital pin 8. Now the output components. Connect servo motor to pin 2, buzzer to pin 5, blue LED to pin 6, and red LED to pin 7, and finally the remaining components, DHT11 sensor to pin 3 and push button to pin 4. Take your time here, this is usually where mistakes happen. If something doesn't work later, the first thing you should check is your wiring. Also, feel free to pause the video and follow the schematic on the screen if you need a visual reference. Once everything is connected, we are ready for the next step. Now comes the fun part, turning this into an actual house. I grabbed a few cardboard boxes and carefully opened them up to get flat sheets. Then I started sketching the walls, roof, and door directly on the cardboard. This is where you can get creative. Your house doesn't have to look exactly like mine. After drawing the shapes, I used a utility knife and scissors to cut everything out. Take your time here and try to keep the cuts clean. It makes a big difference in the final result. To make things easier for you, I created a template with all the dimensions I used. You can find it on the screen and in the description. Once everything was cut, I started assembling the structure. The servo motor goes near the front door, so it can physically open and close it. Right next to it, I placed the rotation sensor so turning the knob feels intuitive. Then I moved to the window area. I installed the infrared sensor and placed the LEDs and buzzer nearby. This is our alarm system. Inside the house, I mounted the DHT11 sensor on one of the walls and measured temperature and humidity. Finally, I placed the LCD screen and push a button on the roof, so the readings are easy to see and interact with. Here's the cool part. When you rotate the knob, the door smoothly opens and closes, but if you try to break in through the window, the alarm instantly triggers, LEDs flashing, buzzer sounding. You can also check the temperature and humidity values on the LCD module. That is your smart home in action. Now let's understand what is happening behind the scenes. At the top of the sketch, we import the required libraries and define all the pins and variables. As projects get more complex, this section naturally grows, and that is completely normal. Inside the setup function, we initialize everything, set pin modes, start communication with the LCD and servo, and configure the button logic to avoid false triggers. Then comes the loop. This is where the system continuously runs. First, we read the rotation sensor and map its values to a servo angle, so when you turn the knob, the door moves accordingly. Next, we handle the push button. Each press toggles between Celsius and Fahrenheit, which updates what is shown on the display. For the DHT11 sensor, we don't just take one reading, we take multiple readings over time and average them. This makes the data more stable and reliable. Then, we monitor the infrared sensor. If it detects something nearby, the system immediately activates the alarm. LEDs blink alternately and buzzer turns on. Finally, we update the LCD with the latest temperature and humidity values in a clean format. If something isn't working as expected, open the serial monitor. It's a great way to debug and see what the system is doing internally. And if you are still not confident with Arduino code, I have a full beginner tutorial about Arduino programming. Make sure to check it out. And just like that, you build your own smart home system. You combine sensors, actuators, and user interfaces into a single project. And that is exactly what real engineering looks like. If something didn't work perfectly on your first try, that's completely normal. Debug it, tweak it, improve it. That's how you learn. In the next lesson, we are going to keep building on this concept, so make sure you are subscribed. And before you go, check out the video on your screen. It will help you understand some of the components we used today in more detail.